Hi everyone, welcome back. In the last video we talked about magnitude function, and today we are going to talk about phase function. This is also used for similar cases just like magnitude function. For example, optical flow, we are using magnitude one. Also phase function we are using for optical kind of cases, we are going to use phase function. Magnitude was just calculating the magnitude, the absolute magnitude of the vectors or complex numbers we can call. In a similar way, phase function is gonna calculate the rotation angle of these 2D vectors. So it's just doing that one. Also, each elements, each maybe pixels we can call, is calculated via on this standard library function, which is the arctangent we can call, is calculated via on this one. Also we are gonna prove this in the example, and the usage is very easy. You are just giving the two input. The first one is gonna be representing the I value of the complex number, and the second one is gonna represent the J value of the complex number, and the angle is gonna be our output. Also you can get the angles in degrees or radians, both you can get the degrees values. Yeah, in here also it's said like that. Let's switch to the code part. In here there is an example from the previous video. In the magnitude video we can use the same example. Let's use this one, and this time we are gonna use the, of course, the not magnitude function but the phase function we are gonna use, and all is done. We can say we can directly see the result. For example, let's see. But you see we already give three inputs. The fourth one we didn't specify, which is defaultly false. So the results we get in the radian degrees. So you need to keep in mind this one. If you specify this as true, which is gonna give the output in this time in the angle degrees, you see in here now these are angles. You can also check, for example, 1 should be equal to 45, let's say, is giving like this. It's not giving the constant but giving this kind of, which is can be easily round to the 45. Also similarly 3, 4, the angle is gonna be 53. Yeah, this is very easy to understand, but I want to prove, because in the documentation it said this is using arctangent. Let's see how to do that. We can basically just make a for loop. Let's define, first of all, since this is 2 by 2, we can make like this, I++, and similarly we can make a for loop for J. So I'm gonna check each pixel, each element of both array, and I'm gonna get the arctan of the values, so we can prove the function, right? And here it's gonna be like this, and J++, and all is done. And here I'm gonna write the result to the console. Okay, and in here I need to call the standard library arctangent. Where is that? This one they are saying, and here we need to call the first one, not the first one, sorry, this is critical. First the Y value, which is the J value of the complex number. So we are gonna take this one firstly. So we are calling the J math and dot at, and since this is float type, and here we need to specify the element, and after that the second one, which is gonna be the I, but corresponding coordinates should be, of course, and it's gonna be I, and all is done. By the way, just to keep in mind, standard library arctangent is gonna give us the output as radian degree. So we need to keep in mind, since this is degree, we need to make this false again. So we can, now we are expecting, according to the documentation, both results should be same. Let's see. Okay, the first one you see is same almost, we can say. Yeah, also the second one and the third one, and continue like that. Yeah, so the results are matching, so we can say, okay, we already proved the function also. Yeah, this function is just simple. You can use for optical flow kind of cases. Also in another case which we cannot assume, maybe in some cases you need to calculate the degree of many elements, so you can easily calculate via on this phase function, because the name is not directly telling us this is calculating the angle, but in reality it's just calculating the rotation angle of 2D vectors. Yeah, for this video I just wanted to talk about this phase function. See you in the next videos.